Welcome back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler. Today, Scott and I are talking about some history here, some topics from way ago, really around the CAD Talk product evolution, kind of how we see integration, and really I want to learn myself about how Scott, how you figured out how to do integrations, and then why you chose to do what you did, and learn a bit more about this problem.
Yeah, absolutely. I think it was this kind of stemmed from like an internal discussion too, right? We had the we have new team members, and we also have the acquisition that we did recently with Elmo, and Elmo works, the ID Link product works a certain way, and the CAD Talk works a different way, and other products out on the market have different ways of working, and I think it's important, and I think we get asked a lot like how we're different,
Yeah.
right? And I think we want to kind of set the record straight of like how that actually was. And a lot of it comes from like decisions that I made back in the early days of the product. So I thought it was probably it's kind of a good discussion to talk about like why we did it, why I did it the way we did it. Right. And this is why kind of the vision behind it and kind of where that is. So today we'll have a little more of a presentation that we go through. This is actually a revised version of what we did internally to, educate the team, but to kind of explain how the product has evolved over time and how we're not just an import tool. We're something more than that, and that's how we differentiate ourselves in the market. But
Which is interesting is that we've had discussions with lots of different tools out there, right? Different either people in different countries or different competitors, and we've looked at kind of all the solutions, very similar solutions out there, even for PLM integrations, and everyone seems to do the problem about the same, right? Like with the exception of us, is they seem to do the same methodology with that. And so I think this would be a good discussion around not just what makes CAD Talk different or unique in this space in terms of integration, but like why those decisions, like why you made those decisions in the first place.
mm-hmm. Yeah, absolutely. Let's dig into it. When I think, like I said, as you know, if Jeff, you can kind of act as the foil here and just ask me kind of like what made what kind of happened there and stuff. What was the driver of that and things like that. But because for those of you who aren't or just on the audio, I'll try to describe the slides as we go as well. But if you're on YouTube, then you can see everything as well. But the main, why this story matters mostly because we are positioning ourselves as an AI kind of intelligence engine, not necessarily a import tool, right? So we get compared a lot in the market to other tools that on the surface seem very similar. They solve the same problem, and then so we get compared to that. But like where they stop, CAD Talk goes way past. It's like we consider what a lot of our competitors to do is table stakes. It's just what you need to do to even solve the problem at all, right? But we are able to do so much more than that, and we really want to start educating the market on like why they want to even do that. Like everybody, I remember when we first built the tool, nobody even understood why they want to do the table stakes thing. Like let's get the thing linked together and copy data back and forth and save on data entry and all these types of things. Of course, yeah, that was actually hard to sell people on in the early 2005 2008 timeframe. Now people pretty much get that, right? But now like you got to take the problem even further and figure out like what is the real job to be done here. The job to be done isn't just to get the thing imported into the ERP. It's more than that. All right. And I think what a lot of the other tools stop is to get it in the ERP and they save you those keystrokes. But that is not the job to be done. That's a very small fraction of the job to be done. Does that kind of make sense, Jeff?
Yeah, no, I mean, having talked with customers, I think that there are many jobs to be done when you're talking about integration.
Mm-hmm.
The importing of the data or the syncing it or the linking it or the copying it or whatever, that data, that is a part of it or can be part of it. That's the beginning of the journey. I always talk about like this is a journey or a spectrum. It's the beginning of that journey. You have to get the data in there. But
Mm-hmm.
beyond that, there's much more work to be done in the whole manufacturing process, the whole data enrichment process. There's more than just copy the data out of CAD or PLM into ERP, right? There's more to it. That's part of it, but there's much more to it.
Yeah, so I think it's our chance to set the record straight, really define what the differentiating factor of this is, and so just get kind of an idea of this is that the way that most tools work, they have this idea of this linky model, right? Where like you're linking the CAD to the ERP or the PDM to the ERP. And the very first version of CAD Talk actually did this. I actually built it this way. And it was, I think the first customer was like a Sightline, version 6, like progress-based system with actually Solid Edge, which is kind of an interesting, we don't see a lot of Solid Edge anymore, but they're still, still out there. And it worked inside of the CAD, is essentially an engineering tool. And it kind of had this syncing kind of idea that we just took data from here and we synced it over there and back and things like that. And it's just a link, right? It's essentially an import tool. So the very first version was that. And it's actually the most intuitive way to look at it. If you're very new to the problem, you're like, hey, and I think when I was actually in engineering, I was like, why am I taking drawings from an engineer who printed them out of an engineering system and then retyping them into a ERP system? Why would I mean, it's all electronic. It started electronic. Why am I going to paper and then to electronic again? Why can't I just save that keystrokes and take it right over? And that's true. It's like that's actually the most intuitive way, but it's a very engineer perspective, right? I think that I think a lot of the tools that are out there, including AnyLink, which is, we acquired, come from an engineer perspective of the problem, right? I used to have to type, like a lot of times in smaller companies too, the engineer has to type that data in and they hate it. And it's a poor use of their time, right? And the bigger companies, you tend to have more manufacturing engineers and things like that. In places which is more like where I came from, we actually had a manufacturing, but still it's kind of a crappy job. It just does that. Especially if you're the engineer doing it, because you're not really adding a lot of value. You're literally just putting the data in as you built it into the ERP, and then you're hoping somebody else deals with it after that. If you're a manufacturing engineer, you're probably adding more value to it, like routings and other data that's more useful. So there's some thinking there. There's actually some value add during the transfer that's interesting. But most of the tools out there are just trying to get the thing off the engineer's plate because they have the engineer perspective of the problem. I got to type this in and it sucks. I don't want to do that anymore. Please import it for me.
Right.
Right.
We see that even with like PLM systems, right? Like not just engineering system, but PLM is an engineering, but it's a product management system, right? Your product lifecycle management. You're getting data there from CAD, from other places, and you're enriching it. It's still got to go to ERP if you're if you're a PLM that does if you're a company that does manufacturing. Not all companies that have PLM do manufacturing. They could have contract manufacturers, but even still, the idea is that you need to get that data into ERP. But there's really this idea that you are just syncing it, that the data is the same, and then you're just going to sort of populate it over there with no other necessary work.
Yeah. It's basically, all it does is automate the silo.
Yeah.
Yeah. I mean, you have these silos, there's engineering silo and you have this manufacturing silo. And I'm like, people talk about throwing stuff over the wall. Right. And, I think it's still a PG podcast. I got to make sure about that. But like you throw stuff over the wall, and all an import tool does is make it easier for you to throw it over the wall, make it somebody else's problem. Because if you can't make the thing, you didn't solve the problem. You didn't get the job done. The whole purpose of a manufacturing company is to make things to sell to customers to collect money. If all you did was make it so the engineer didn't have to type, you didn't solve the problem. You just solved his problem. You didn't solve the manufacturer's problem, which I need to get it out of the engineer's mind into a good that I can sell and make money on. That's the actual job. Make the thing. And to order to get it made, it has to get out of the engineer's mind into an ERP system so we can figure out how to make the thing. And then once we know how to make the thing, we can make it and sell it and collect money. There's a lot of things that have to happen before then. An import tool just does this little piece and then still makes it somebody else's problem. Somebody still has to figure out who we're going to buy it from, how much it's going to cost. If we're manufacturing it, what do I need to do with it? All these other things have to happen. The manufacturing organization has to figure those out in order for this thing to be made so you could sell it to a customer. So I think the example I used during this presentation internally was, until we figure out how to create like antimatter replicators like we have in Star Trek, where you literally just take the idea that you have and it just generates it out of antimatter, like somebody has to figure out how to make the darn thing, right? That's what the ERP does, right? So like until we do that, like the import tool is only just getting it, it's basically throwing it over the wall for somebody else to figure that out. CAD Talk is trying to do more of that figuring out for you. It's trying to do more of that work. And that's the differentiation right there. It's like, we're not just throwing it over and saying, okay, people on the engineering, people on the ERP world, go figure this stuff out. We're saying, what are they doing with it after it gets there? And can we do that work for them? Can we help them with that job to be done? Does that kind of make sense, Jeff? Or
Yeah. So yes, it does. And what I typically see is, or when I talk to lots of customers, is that you're absolutely right. The initial idea is I need to get the data in there. They don't think too much about the fact that if you just sync the data as is in engineering, that isn't always the way that you need to have it in manufacturing. I mean, I've seen so many times that in manufacturing, you need to change the structure of the bill. You may need to flatten it. You may need to move it to different operations. You may need to enrich it further. There's that structure can change quite a bit coming out of engineering. But if you, I mean, I remember having at least one customer say, yeah, we could import it, but once it was imported, if I needed to then like basically almost delete everything and rebuild it from scratch because it wasn't in the format that I needed it. We don't make it like that.
right. I mean, it's kind of like we're showing this slide, right? We're saying assumes the CAD and the ERP are symmetric, which is like we had this idea of an engineering bill of material and a manufacturing bill of material, right? And your assumption is that they're the same thing. Because the only way that you could sync is assume that you're talking about something similar or the same thing, right? It's like, and a lot of times the M-BOM and the E-BOM are not the same, actually, by definition. Like, why would you have different names for it if they were the same thing, right? So the syncing idea kind of falls apart. It breaks down because like things like raw materials, routings, those aren't in CAD. And then linking kind of forces this symmetry. Like sometimes people will be like, well, I can't really do routings because I don't have the routings in my CAD. So why do we have to have them there? Why can't we derive that? We derive them when we do it manually.
Right.
There's a manufacturing engineer figuring that out, like based off of the stuff that's in the model already. Like this idea, but if you say they have to sync or they're linked, then you're duplicating data in both places, and it's useless to like what the engineer doesn't care how you make it. And by the time he's designed it, like it's already just kind of decided, right? Like you really want something. You really wanted to have that decision made while he was designing, not after he decided, right? And so it's just kind of this assumption that that these things are the same is wrong. And like, and the M-BOM is really what drives the thing to get completed, right? The M-BOM is what the ERP needs. Now, if you're a super simple manufacturer and there's times where you don't build anything, and the M-BOM and the E-BOM are very, very similar.
Mm-hmm.
That's a very easy case. Okay. Maybe you just need an import tool. Maybe we're not a fit for you. That's fine. But like generally, if you have an ERP and you're doing these things, you're probably doing something more complex than taking a bill of material, printing it out. In that case, just print the drawing out and tell the people in the shop to make it. You don't need an ERP. You know what I'm saying? Like it's pretty simple at that point, right? But like if you have an ERP, then you kind of have a little bit more sophistication around how you're making the thing. So you probably have some form of a differentiation between an M-BOM and E-BOM, which is what we helped you do. Where our job is to transform the E-BOM into an M-BOM, not to put the E-BOM in the ERP and tell it and say good luck.
Right. No, I mean, Well, I think what you said about silos is right. Is that because I've had lots of conversations when if I talk about when in the sales or I educate the sales team around like, hey, you can create routings in CAD Talk, and then the common objection will be like, I don't keep routings in my model. I'm like, well, right, but like, do you use routings? Well, I don't know. Well, someone in your organization uses routings, don't they? I don't know. Well, get them on, let's ask them. Yeah, we use routings. Well, and I step through the process of like, well, how do you know what the routings are? Well, I look at the drawing.
Right. Yeah. And like, So you derive them.
You figure them out based upon what the drawing says. Yes.
Yeah, like what a concept. You're deriving it from the design. You're transforming the engineering intent into the manufacturing execution. That's what that. See, there's like, and I think like people don't realize that they're like, oh, I see it over here, and then somebody's going to figure that out. And it's like, well, couldn't we help them figure that out? Could we help with that job? So you see how the job. So everybody's thinking about the job as being this, and the job's actually this, right? And if you compare looking at like, well, does this tool do this job for me? Yes. Does this tool do this job for me? Yes. Maybe this second tool costs a lot more. Why? Because it does this, right? And that's a totally different thing. You're not comparing, you're not, it's differentiation. That's what differentiates you in the markets, right? It's the tool is a different thing that we're talking about.
Tell me a little bit about like, how did you said you built it one way in the beginning, right? The most intuitive way, which was like, hey, let's copy the data from here to here. Let's link them together. Let's put these two things together. That was the most intuitive way. And that's typically what people think of when they want to solve that problem. You know, they might talk about import, or they might, now some customers will come and say, no, I want to translate the data, but they say, I want to import the data or link it together. But so that they have that mindset. You had it too when you first started. What was the thing? What was the action that made you go, I need to think about this in a different way?
Yeah, I mean that's great. Like the breakthrough was like thinking that, like it was basically the idea. I think the raw material problem is what actually clued me in on this, because like and it really kind of gave me this idea that it was more of a transformation, and that there was this I don't think I even knew what an E-BOM was or M-BOM was back then, but it was I'm sure the term even existed, but it was like the raw material was interesting because raw material a lot of times in CAD systems is just a property on the design, right? You just have this design. But in the ERP system, if you're making something, you know, like the raw material is like a subcomponent. You're making the thing out of the raw material, and you usually have a routing that says like, let's use the example of a saw. You cut the raw material at the saw, then you drill some holes in it with like a vertical, and then it becomes a part. Or you cut it with a laser. Or, you know, there's some kind of things that happen. So the way you model that in ERP is by using a subcomponent of a quantity. And in order to transform it, you couldn't just take the property and make a subpart out of it. You had to have, you're transforming it, because the bill of material on a drawing, on an engineering doesn't show raw material. It just says it's a property. It's like an attribute of it. But you had to transform it into a completely different thing on its own bill. And then how do you link that? Like, how do I know that, like, if I change that part that's on the bill, what CAD file am I updating? If I change that, there isn't anything, you know, it's like nothing, there's nothing really to work with. So it became like the syncing became kind of hard, because you have like, in order to solve more of the problem, which is that transformation, you kind of broke the link. Okay. Because at the end of the day, what people really worry about, this is the thing that like probably more controversial. Everybody's like, well, it should be linked. That seems correct, right? Well, they should be the same. Well, yeah, but like the linking is the problem. It's like, and then you go, what do you want to link? And people go, well, quantity and description and part numbers. Okay. Anything else? No. I'm like, all right. So like might have a couple different things from that, but then you're like, well, if the description changes, you should write it back. And I'm like, why are you changing the description? Well, we like the description better. Well, if it doesn't matter? Yeah. Then why isn't it going back to engineering to do an engineering change? Well, it's just a description. Well, either it matters or it doesn't, right? It's like, you can't have it both ways, right? It's like, so this idea, because I think a lot of engineers are like, well, you're changing if you change something in my design, you're changing my intent. Okay. So the idea is like, we should link, because I don't want you changing my intent, but they change the intent all the time. They're just dumping their intent over here, and then they change it for the manufacturing process. You're not changing the intent to create the M-BOM, right? You're describing how you're going to do their intent with the M-BOM, which isn't described in their model, at least not directly. So the idea of linking broke down, because you're assuming that they're apples to apples. They're apples and oranges. You can't compare them. They're two different things. They have, like, I think of it more like a derivation or a derivative. Let's use like calculus, right? The engineering thing the manufacturing BOM is a derivative of the engineering BOM. It has elements that are similar, but it has more, right? And That's why we even internally, we don't even like using the term like linking or mapping or any of that kind of stuff. We use transformations as the term because that describes more exactly what's happening. You're transforming it from this engineering data into to enable production. You're trying to turn it from engineering intent to manufacturing execution. You're converting it. So that idea, it became really, really hard to answer your question, to make the linking work and also do the whole job. So we just said, don't do that. Like, do you have solutions for that problem they're talking about before? Yes, we have solutions for that. But it's where the evolution came. It was like, let's not try to link it. Let's just make it a transformation. Does that make sense? Or
Yes, it does. So when you were looking at that problem and you thought, okay, I got to go beyond this, and raw material was one of those attributes, and so was routing steps, and now of course we have all kinds of other attributes like documents and steps and revisions and all kinds of other pieces of data beyond just this CAD structure. So seems even more relevant than it seems even more relevant now than it was maybe when you first did it, because there's so much more that isn't even in the CAD model.
right, and it shouldn't be. Like, people, like, why does it need to be there? Like, if it has no value to the engineer, or doesn't need to be on the drawing for any reason, there isn't any reason to put it there. It's like this idea, like, people will talk about like product codes, right? And they're like, well, how do I set the product code in the ERP? Why do you put a product code in the CAD? So you're asking the engineer to put things in, they have no idea what it is. Like, why? Like, they weren't going to put the product code in there before. It has no effect on the design. It's something the ERP needs. So why does it need to be in the CAD at all? All you have to do is have a way to figure out what the product code is based on what they've already done. Well, somebody knows that. Like, if somebody's doing it by hand, they would say, oh, this is like such and such thing that we're doing. It's product code 2. Well, great. They were able to figure that out without putting the product code in the darn drawing. Why can't the software do that, right? But you just right there, you broke the link, because if there's no both sides, there's nothing link anymore.
Right. There's no linking to product codes, because product codes don't exist in CAD. They're not a CAD equivalent. Nobody cares. Nobody in engineering cares what a product code is. And a lot of times engineers don't even care if it's manufactured or purchased. They don't even care.
And
All
like,
they
why?
care is that, like, I need this part made out of this material. I don't
Yeah.
care whether you get that made outside or inside. I don't really care.
Hmm. Now, you could argue if they should care or not, but like, that's a different discussion. Like, if you're doing true manufacturing engineering, you would work with the engineer during design phase. You would design for manufacturing, which is a little bit of a preview to what we're going to talk about later. But that's what you would do to solve that problem, not syncing something. Syncing something doesn't do, like, that's just a data issue. That has nothing to do with true engineering or true design for engineering or any like design for manufacturing. And it doesn't solve that problem. It just makes you feel good because they're linked. It doesn't really solve. It doesn't do anything, right? So, and that's a hard stance. I know. I mean, this is probably controversial. We have a lot of people would argue with me, especially engineers, because we have opinions, right? But like, really think about it. Like, why does it matter, right? And it doesn't really. Like, it doesn't. You know, and I'm sure there's use cases people would say there's difference, but I mean, I've had this discussion many, many times, and it's really hard to make the case. It just feels right. It's one of those things that feels like it should be right. You should do that, but it doesn't actually make any sense. So yeah, like, CAD Talk's not a sync tool. It's a transformation engine. And it handles its complexity. And it's like, and the reason why I think it's something different from the other tools is that we came at this. I worked all of these jobs. I worked as a manufacturing engineer. I worked on the ERP side. I worked as a design engineer. I worked in all of the jobs. Most of the other tools come from engineers who just design stuff. So we look at
Who
this
want to
problem,
avoid going into the ERP.
right? They like, just get it off my plate, but you have to then. So when you live in all of these different worlds, you understand all the challenges with all the different areas. So it's not a silo anymore. So sometimes we'll look at a problem and we'll go, you know what? Yes, it's a little bit more work for the engineer here, but that's going to save 10 times the work over here. For a lot of these other tools, just figure out, let's save the engineer that 10 minutes of work, and I don't care if it creates 3 hours downstream. And that's the way that people approach it, because they're looking at silos. And you need to look at the whole process. What are you trying to do? I'm trying to get it out of engineering and made so we can sell it. How much of that can I help them with? That's the problem we're trying to solve.
Yeah, it's like kind of like I was just thinking this kind of related like a knock-on effects, like where um, you try. I don't know. You might know this a bit better than I do, because especially in like in engineering, it was like you make a change over here that seems reasonable, and then but over here, it's caused all these other problems that you didn't think about, right? So that's a common, I mean, that's a common occurrence, just kind of everywhere. Whereas like you micro optimize on one end and then a chain reaction everywhere else.
Oh yeah. Well, that's a lot. It's system theory and things like that. You see that a lot. It's like a series of good decisions on the micro lead to a macro bad result. And like all these, because you have all these little micro optimizations without taking into effect the entire system. You see this in nesting too. So like people who do nesting, you nest a part a certain way, and then you say, oh, the most efficient way to do the next one is to put this here. And then you have this kind of crooked nest that basically creates a big remnant at the end and doesn't make any sense. Whereas if you looked at the thing holistically first and then you backed out, you would straighten that part, even though by straightening that part, it had slightly less utilization of the sheet, but it made it more symmetrical for the next part to come in. So the same thing happens in process. If you think about, you optimize for like what the engineer's got to do, you'll make decisions that compromise what's done. You see this all the time in engineering. It's like, well, I can make this part. We used to do this like another example that's like we used to do this with materials, like for design for manufacturing. Like they'll design parts and they'll say, well, I want the part to be cheaper. So they'll optimize every part and they'll switch raw materials for a whole, they'll build this assembly and they'll use like 6 different raw materials to make it, or 10, right? Because they were trying to optimize each part to be cheaper. Like, well, if I don't need 1/4 inch, I'll use 7 gauge, and they'll change all that stuff. And that's a good decision on a micro. Each part is cheaper, but you're going to make the thing on all the parts are made on a laser. If I use 7 different materials, I got to change out 7 different sheets to make one assembly to ship the thing to make money. So if I say, well, yeah, I might be over engineering this a little bit, but I'm going to make everything out of 7 gauge, or I'm going to make everything out of 3/4, wherever it is. Now I've got 2 changes of material to make that as parts. I can get an assembly created, put together, sold, and collect the money faster. So optimizing on the lead time actually saved more money than I did trying to optimize on saving a little bit of material. But that's just an example of thinking in the micro can affect the macro so much more. And that's so like standardizing on those types of things could really give you a lot, can really do a lot for you as a manufacturer. And just the same thing with thinking about this process, thinking about the macro with the whole thing you're trying to accomplish, not just how do I save the engineer some keystrokes,
Right.
like it's really just that's table stakes. Like that doesn't even, it's like, I don't know. I just find it's not that interesting at the end of the day, because you're not really solving the real problem. So I think that like I said, the market confusion, the market sees that sometimes as a fancier and linking tool, but we're solving a much bigger problem. Like think about this guy taking these steps, like, if you're syncing, you're only taking a couple steps. Whereas like, if you're doing the other thing, you're trying to complete that entire process. You're getting all the way up the steps, not just doing the first step, which is, we solve a deeper problem with a smarter architecture. We're trying to do more of the work, more of the job to be done. And I think you see this all the time in the sales side, Jeff. I mean, you see a lot of market confusion, right?
Mm-hmm. Yeah, I mean, because like for every solution out there, every product, I mean, products are always come from problems people are trying to solve, right? Customers don't care about your product. They don't care about what you do. They don't care. I mean, just like I don't care about most other things, but I have problems that I need to solve. I need to solve a problem, and I want a tool. I want something that's going to solve my problem, right? It's all problem. So first thing you need is customers have to be problem aware. Do they aware that this is a problem? And the first problem they're aware of is the person has to do the work, right?
Mm-hmm.
So what's the work? If you're the one, and let's be honest, engineers can be tough people. So they're like, I don't want to do this work. I don't want to be in ERP. I don't want to be in PLM. I don't want to be in these other systems. I just want to do my CAD and be done. I don't want to be messed with that. So they'll say like, I don't want to do this. So they'll raise my hand and go, this is the problem. What's the problem, right? I have a problem here. I don't want to enter this data, right? I shouldn't be doing this. And he's right, or she's right. It's not valuable for have them typing in stuff manually. They need to solve that problem. So great. And then what will happen is they'll look for a solution, or they will say, I want to solve that problem. And then the initial problem is I don't want to enter the data. You're absolutely right. That's where because that's what comes to that person initially.
Yeah.
And so that's what we typically get. And that's why you will hear like people want to say on 9 out of 10 calls, what are you trying to do? I'm trying to save time and reduce manual entry. That's most of the time what they need. I want to reduce manual entry, and Stop doing that. We just want to get the data in there. But if you're an engineer, you're not thinking about what the data needs to look like on the other end. Now, typically when we're in the call when we're in a sales call and my team's in the call, you need to invite more than just the engineering team. You need to invite downstream people because it's going to affect them, and then begin to broaden the scope of like what we're talking about here, right? We're not just solving an engineer's problem, right, or a manufacturing engineer's problem. We're trying to solve the entire problem, as you mentioned, from design all the way into the fully manufactured BOM. And so that's what I typically hear is people come to us first for, hey, I got this problem, can you solve it? But you have to expand that and explain, like, well, wait a minute, what's the real problem? Can we get people downstream in this conversation so we can say, like, well, even if I could get that data in there, what else do you need to do before you can release it to the shop floor? Seeing all of that is where you can say, oh, well, there's actually a bigger problem here.
There's more jobs to be done, right? There's more things that have to be done, right? It's like, and that it totally makes sense. People want to optimize what they know about, and and it's not a fault of the people. And I think, we have different workflows that we enable. We actually have cases where the engineer doesn't have to be involved at all. We actually can read the CAD data directly without the CAD system. Like, the idea that this thing needs to be in a CAD system is actually another area where we're different. We don't require that. We can read the data directly from the files. There's all different ways to do it. So you can enable all these different workflows based on what makes sense for your organization. But I would say, as a kind of a summary, is if you're thinking that you have to do it because, it's like, just because an engineer designed it doesn't mean it has to be an engineer's tool.
Right.
You just have to figure out how to get what the engineer design, their intent, into something you can make. That's actually the thing we're trying to solve. How we get there, there's lots of ways to get there. It just depends on, who best knows what should happen. And in some cases, it could just be automated. There doesn't have to be anybody does it. It can be it's run on a server somewhere and just happen, and assuming that we can figure everything out from design. So I think that we see that the problem needs to be thought about differently than just like, how do I save this engineer some typing, which is kind of like it's the wrong, it's only part of the problem.
It's the first step on the ladder, or in your image, it's the first step. The first step is eliminate that manual entry. Step one. Okay. If I do that, does that solve the whole problem? And if you ask that, I'm sure you'll get, well, that doesn't solve the whole problem. It solves the main problem, but not the whole problem. Okay, well, what's the whole problem? And then you start talking about, well, I need to add routings, I need to add raw materials, I need to add paint and outside processes and all these other aspects of it after the fact.
And I think people don't even consider the fact that could be done too. Right? All they could think about is, well, at least you can get it over there and then I can do something with it.
Yeah.
And then the idea that you could actually automate almost all of this, or automate large portions of it, or figure things out like a person would using AI and different tools, is not something people considered in the past. So yeah, it's like just more of the problem to be done. So I know we're going to run short on time, but like, another concept that I wanted to talk about was this idea that we have a tool called Design for Manufacturing, which this is a different way of looking at it. So a lot of syncing arguments come from the idea that like part numbers and part numbers and like subscriptions to synchronize. So a lot of what forces a lot of tools to be inside the CAD is because they're trying to do syncing. And in order to sync, you have to have write access to the CAD models or to the PDM, or you have to have all these the thing has to be checked out. There's all this like rigmarole that has to happen in order to sync it, because you have to have access to edit it. And the question becomes like, well, why are we doing that at the time of bringing the data over? Should we let that stuff be determined? So what we do is when we have a tool that sits inside of the CAD called DFM that allows you to put this data into the model to prepare it to be imported. So why don't we have it so people can issue part numbers from the ERP, or they could pick from the raw material in the ERP during design stage, so it populates the model so it's ready to be brought in to the ERP later. And instead of trying to do this crazy syncing back and forth and putting it back in all this stuff, we just put it in the model to begin with, let them see what's available, let them see the data, issue the thing from the ERP, put it in there, and then when it runs through, it just goes right into the ERP, ready to go. And that's what DFM was designed to accomplish. It's a different way of solving that problem. We issue the numbers up front. We pick the raw material up front. it makes it really easy for the engineer to make good decisions during the design stage, which prevents most of this syncing problem that people are trying to do. So so I think we're going to go into more detail about DFM in a future episode, just because we have to run short on time today. But I think it's a great discussion to key in on DFM and what the use cases are. So, all right, Jeff.
Thanks.
Yeah.
Thanks a lot, Scott. This has been a good podcast to understand, kind of the thought process and transformations and in terms of integration. So I look forward to talking about the design for manufacturing next time and really help people think about the whole process, not just getting data into the target system.